I'd like to talk about end behavior of polynomials. So let's go to Desmos. I'm going to share my screen. All right, here we are in Desmos. And what I mean by end behavior is on the end, as you go towards minus infinity or positive infinity, what does the function do on those end, this end and this end? Well, we can't really see the function. Here's where it cuts off, but you can see what's happening. As we head to the left here, this function goes off to positive infinity in the, vertically, heads up forever. And then as we head to the right, in this polynomial also heads up infinitely. So you can see we have a situation here where on the ends of the polynomial, it's going off to positive infinity. Now, what if I change something about this polynomial? What if instead of 1/4, I have negative 1/4? Do you have an idea of what might happen? It's not going to be a reflection across the x-axis, because in order to get a reflection across the x-axis, you would have to multiply every term by the negative. Okay, so this would have to be negative and this would have to be positive. I'm just going to change the leading term. Okay, so it's not a reflection, but look what happens. Now my function is heading down to negative infinity. As you head to the left and as you head to the right, the function is heading down to negative infinity, just from changing that leading sign. That's how powerful the leading term is. It matters what this sign is in front. The function is going to behave very differently if you have a different sign in front. It's all about the leading term. So the other terms they have exponents on them, but nothing is as powerful as that leading term because it has the highest exponent. So as you put higher and higher numbers, or if you put lower, like more negative numbers, and you get off to minus infinity or positive infinity, you're going to cause that leading term to become the most powerful, and it's going to determine the end behavior of the polynomial. So it doesn't really matter what happens in the middle. It's the ends that we're looking at here. So now what if I change the degree to, notice this degree is even. What if I put an odd number in there? So like, let's say this becomes 3. Okay. Now, if we just look at end behavior, notice that instead of both ends going in the same direction, they're going in opposite directions. Because negative numbers, that leading term is, you're going to multiply by negative. And it doesn't really matter what happens after. It's that leading term that's most powerful. So if you put an x in there and you put, like, say, negative 100, that cube of that negative 100 is going to be way more powerful than a square of the negative 100. So those negative values of x are going to then be multiplied by another negative, and so they're going to become positive. So the cube preserves the sign of your input, whereas the even power is going to negate the sign. So if it's a negative, it's going to be positive. If it's a positive, it's a positive. It just, when you put any number into an even power or an x that has an even power on it, it's going to be positive. And then if you multiply it by a negative, it's going to then change to negative. So that's what's happening here to the right. As we pick large positive numbers, then we put them into the function is going to go down to the negative infinity, because that's negative in front is driving the sign. And here you're putting in negative values, which when you have a cube are going to still be negative, and then you multiply by negative and it's going to drive that to positive infinity. So the end behavior for an odd powered leading term polynomial is going to have opposite tendencies. One's going to go off to positive infinity and the other one's going to go off to negative infinity. However, if they're even, they're going to go in the same direction, and you're going to be looking at the sign to determine, is it up or is it down? Just like the sign here tells us the left is up, the right is down. But if I change that to a positive, then it flips. The left goes down to negative infinity and the right goes up to positive infinity. So here's the rule. Even power, positive leading coefficient, they both go up. If you have an even leading power and negative coefficient, they're both going to go down. And then if it's an odd power with a positive leading coefficient, it's going to be to the right, it's going to go up. To the left, it's going to go down. Okay, like this. I think I might be doing the mirror image of that, but anyway. And then if it's negative, you're going to have it reversed. So just be aware that it will impact the end. Those are the things that impact the end behavior of your polynomial. It's the degree and it's the sign of the leading coefficient that matters.